Hello and welcome to a tutorial on spot weld programming with Severi in Visual Components OLP.
When following any tutorial, check the lesson on the Visual Components Academy, and if the Download Files option appears, you can download the example files.
Hello and welcome to the spot welding tutorial. In this tutorial, we are going to take a look at different spot welding tools, the manual spot welding tool and the spot weld importer tool. In this example layout, we have a simple configuration of a robot that has a end of arm tool, and the end of arm tool is mounted with a moving piston that the robot controls as an external axis. We also have a simple workpiece there in the middle of the cell that is mounted on a fixture that has some clamps holding the workpiece together. To program the robot, we're going to go to the Program tab. We're going to click on the robot so we can change the base and tool configuration. In this layout, we already have the correct tool set up. So we have Spot TCP that is now at the tip of the welding gun. We also have the external axis so we can move the piston or open and close it if necessary. To create spot welds for the workpiece, we're going to use the spot configuration on the hover panel, and we're going to first select the manual spot weld tool. When we click on the tool, it allows us to select a position from the workpiece, where we with just one click can select the position for the spot weld. Then we can see the left hand side in the program editor, everything about the spot weld, and on the right hand side, all the details within that spot weld that we can modify and configure. When we move into the spot weld, we can see that the approach motion seems to be quite correct, but it's not going further enough. And if we enable our collision detection, we could see if there is any possible collision between the actual torch geometry or the robot and the workpiece. We can see this by moving the arm further away. The actual contact tips are not included in this collision detection because they will anyways contact with the workpiece. We're going to go to the path setup window. To open the tool, we can apply a value inside the aux stats, so we could put -100. So then when we open and close the tool, we can get the suitable behavior out of the welding gun. Then, if we would like, we can also modify the angles for the tool, so we can twist the tool further away or in different angles if necessary, or flick the tool orientation. We can also apply various offsets on the position if necessary to perform the correct location. In the Path tab, we can set the via points for our spot weld, so we can increase the length for the via points, so we can get the approach and departure motion correct also for the welding gun. And in this case, we can easily approach and depart from this position. Last step would be to set the welding parameters correct, and these are always custom depending on the actual installation and the application in this robot cell. In this case, we could set the suitable closing speed, process time, and plate thickness so we can provide the correct parameters for the actual robot. You can see an example set of parameters that are necessary, for example, for a KUKA controller in this case. When we have set a suitable set of parameters, we can set these ones to the template list. So we can create a spot WPS template where we include all of these settings from all the tabs above. We can click on the plus icon. That will help us to save this template. And when we have saved this template, it will be automatically in use also all around the other workpiece. So in this case, we could come to the other side, and we could, for example, select a new manual spot weld on this side. That will create the exact same path with the same options that we previously did, and now also with the correct approach motion. And this is how you do a simple manual spot weld. We can also do an imported path, so we can import spot weld paths from this hover panel. We can add a new button to the hover panel, and on mouse right, we can add an action for the spot importer. And if you already have your data inside a CSV file, we can import that data and form these paths automatically from those CSV files. For more information about the CSV files, please check out the data that is provided together with this tutorial. We're going to use the example data that you can find from the tutorial, and we're going to select the import files. You will be prompted about selecting the workpiece component first, so you need to have the workpiece selected. And this is important because all the spot welds are created with respect to the origin of the selected workpiece component. So we're going to select our workpiece, and we're going to select the spot importer tool. Then we're going to select the spot data, and it will create all the necessary spot welds in the background. Now you can see a list of imported spot welds. They have a custom naming and they have a custom order, and all of these settings you can manually define in the CSV file. If you have a way of automatically creating these files, you can include all the data fields that are mentioned inside the CSV and the Excel sheet provided together with this tutorial. The last thing to check in the importer case would be to check with path check tool whether the imported sequence will be okay to execute, so we can run it. So it seems that the first part should be okay. In the second one, we have some collisions and problems with some singularities. So this can happen when you design your spot welds in another software. You probably are not able to see how well does the robot execute those motions, but in this case, we can go to that specific spot weld by clicking on the name. We're going to zoom in closer, and we're going to see where the problem is coming from. So in this case, we have a collision with the base of the welding thumb and the base of the fixture. So in this case, when we want to modify this, we can control the angle for our tool so that in the clamping part, we are out of the collision with this gun and the fixture. And then we can control with full modification, how do we then approach and depart that position, and how far are we going to create the approach and departure motions. So in this case, we're only going to need the approach motion. So let's check again. So we are 100%. So this minor change was necessary so that we can get a program that is then rid of collision. So we are 100% and able to translate this to the real robot. That's all about the manual spot importer tool and the spot importer automatic tool. So thank you for following this tutorial. We'll see you next time.